All right. Now, in astronomy and astrophysics and physics classes and any physical science, we deal with equations. Okay? And equations are something that cause a lot of students fear and anxiety, but they're incredibly useful, and they're actually very, very simple. Okay? An equation basically just relates quantities on one side of the equal sign, a quantity or quantities on one side of an equal sign, to a bunch of quantities on the other side of the equal sign. Okay? So, for example, you're going to get an equation later on in the course, F equals G M1 M2 over R squared. Don't let that scare you because we don't know what that is just yet, but we'll get to that. That's the equation for gravity. But what it's saying is this quantity on the left is equal to this whole bunch of quantities on the right put together in a certain way. Okay? But what you can do is you can think of an equation kind of like a balance in a chemistry class, where you've got, one side and another side, and they're balanced. Okay? So in other words, if you've got a bunch of stuff on one side, and then you got a bunch of other things on the other side, the equal sign, whenever you have an equal sign, it means that this side is balanced with this side. Okay? So in other words, the stuff on the left is equal to the stuff on the right. Okay? So in algebra, whenever you see that equal sign, it's saying that the two sides are balanced. That whatever you have on this side is equal to whatever you have on the other side. Now, in most cases, in a 100 level course like this, we're really only going to be doing simple algebra. For example, you might want to find one of these quantities on this side, or one of the quantities on this side. Okay? You want to find the unknown. Now, first of all, you don't have to take the unknown and put it on the left. The unknown could stay on the right if it's on the right. Okay? You have to try to have it by itself eventually, but we'll get to that in a minute. Okay? But the point is, whatever you do to this equation, you have to make sure that the equal sign is true. You have to make sure that the two sides are balanced. So, for example, if you got rid of half on the right, well then, this would go up and this would go down. They would be out of balance, right? So how do you get it back in balance? How do you get it to be an equation again if you got rid of half on this side? Well, hopefully, you said that you get rid of half on this side. Get rid of half on this side, and it's back in balance again. Now, the two sides are equal, and you have a balance. So this is the golden rule of algebra. Okay? What I like to call the golden rule of algebra. Okay. Whatever you do to one side of an equation you must do to the other side. Because if you don't do the same thing to both sides, it's no longer in balance. It's no longer an equation. Okay? So let's do an example. And again, just like with the scientific notation, I'm going to start off with an example that's so simple that we would never actually use this method to solve it, because we could probably do it in our head, or at least I hope so. So let's say we have an equation A equals B times C. And I happen to know that A is equal to 15 and B is equal to 5, and I want to know what C is. Okay? Well, hopefully you can guess what C is going to be. Okay, A is equal to, 15 is equal to 5 times what? All right, well, you could probably do this in your head, and most people would immediately throw numbers in to this equation, okay? I encourage you not to do either of those things, okay? What we want to do here is to show you how algebra should work if you do it properly. So, first what you want to do is identify what you know and what you don't know. I like to put little check marks on top of what I know and a little question mark on what I'm looking for. Okay? I know what A is 15. I know what B is 5. I want to know what C is. So C is my unknown. I don't call it X suddenly because X is mysterious, okay? But I keep it as C. Okay? Now what I want to do, okay, is the goal. The goal of algebra, the goal of at least this kind of simple algebra, is to isolate the unknown quantity. On one side of the equation. Isolate the unknown quantity on one side of the equation. So you want to figure out what C is. You know what A is, you know what B is. But in this case, B is being multiplied by C. C and B are multiplied together. So you want to get rid of B. How do you get rid of B? Well, if B is multiplying C, you want to do the opposite process. And the opposite of multiplication is division. So you want to divide out B. But again, let's go back to the golden rule of algebra. If you divide by B on this side, what else do you have to do? Well, you have to divide by B on this side. So B divided by B on this side is 1. B divided by B is 1, whatever B is. In this case it's 5. 5 divided by 5 is 1. So you basically, it goes away, or it turns into 1, and you don't have to worry about it anymore. Here, A divided by B is something, but instead of throwing the numbers in right away, let's just write it down. A divided by B is equal to C. Okay? Now the algebra is all done. The rest is just arithmetic. I encourage you, and I know a lot of people tend to really resist this. What they want to do is they want to throw numbers in the first thing and then manipulate the numbers. It is my experience over many, many years of doing this that the sooner you put numbers in, the sooner you make a mathematical error. Okay? So the best thing to do is to try to manipulate the symbols first. Then when you get down to this part where the thing you're looking for is all by itself and the stuff you know is all by itself on the other side, that's when you throw the numbers in. So now you plug in 15 for A and you plug in 5 for B, and what you have is 15 divided by 5 is equal to C. 15 divided by 5 is 3, so 3 is equal to C. Okay, so there's your answer. You're so happy about it, you draw a blue box around it. And there you go. Notice the unknown didn't have to be on the left-hand side. I didn't have to have C is equal to 3. 3 is equal to C. So what? So it's on the right. Big deal. Okay, so that doesn't matter either. Okay. So again, this was a real simple example. We would never use such a long method to do it because we could do it in our head, but I just wanted to show you that it works. All right. Let's try something a little more realistic, and one that people get wrong because, well, from experience I know that people get this wrong. Let's say that you're going to go visit a friend this weekend, okay? And you want to find out how long it's going to take you to drive there, okay? So you look up your friend's address on MapQuest or whatever, and it tells you that your friend's distance to his house is 180 miles, okay? Now, you happen to also know that speed is equal to distance divided by time. Okay, speed is distance divided by time. This is an actual equation from actual physics. Okay? You know the distance is 180 miles. You know that your speed is probably going to average about 60. Okay? So in other words, you live slightly off the interstate, your friend lives slightly off the interstate. When you're on the interstate, let's say that you're driving the speed limit 65, but because there's going to be some roads that are not as perfect and probably some construction and probably the occasional traffic delay, you're going to average, say, 60 miles an hour. Okay? So 60 miles per hour. Okay. And again, because this is astronomy 1, let's not even worry about the units. Okay? Let's just not worry about the units. But you want to know how long it's going to take you to drive there. Okay? How long is this going to take? Well, again, some of you might be able to do this in your head. All right? But let's not do that. Let's say, all right, let's do a little algebra here. I know what D is, I know what S is, I want to know what T is. So I know D, I know S, I'm looking for T. So again, what you want to do is isolate the unknown quantity. In this case, the unknown quantity is T. So try to do that. Okay? In other words, hit pause, try to isolate T, and see how it goes. Okay? And then come back to it once you have T is equal to something or something is equal to T. All right. Now this is a little bit tricky because the T is on the bottom of the fraction. It's D divided by T. Okay? So some of you might have said, well, let's divide by D. If you did that, if you divided by D, then you would have gotten S over D is equal to 1 over T. And that doesn't really help you that much because you want to get T in the numerator. It's in the denominator now, you want to get it in the numerator. So that seems like a good first step, but again, it's not a bad thing to do because in algebra you have to practice, you have to try things, you have to, learn by trial and error. And in this case, that was the wrong first move. It turns out that the right first move is to multiply both sides by T. Okay? Because T is being divided on this side, you multiply it, and the T's cancel out on the right side, and so you have T times S is equal to D. And you might think, well, wait a minute. It's no simpler because I have T times S on this side. T is not isolated. And that's true, but at least it's not in the denominator anymore. Okay? You have a T here times S is equal to D. But now it's one more step, one more simple step to isolate the T. All you have to do is divide both sides by S. T is being multiplied by S. Let's divide out S. If you do it on this side, you must do it on this side. So you divide out the S, and you have T is equal to D over S. And now, and only now, you are ready to plug in the numbers. And by the way, if you don't do it methodically like this, I have had physics majors tell me that time is equal to distance times speed, or time is equal to speed divided by distance. Okay? You got to do it according to the rules to get down to the proper form, or else it just doesn't make sense. So I encourage you to do things step by step so that you get it right. Okay, so in this case, D is 180 and S is 60. So you have the time is going to be 180 divided by 60, which is 3. So T is equal to 3. It's going to take you 3 hours to get to your friend's house. Okay?